Dear friends, engineers, architects, this particular series is about electrical AC motor starters. As you know, mm, the electrical motors are very prominent in automation of working of everybody, whether it is a AC motor driving pump, whether it is AC motor driving other industrial applications. We cannot live without AC motors. And if there are electrical motors, the starter are also needed. Now, electrical motors may be synchronous or asynchronous type. Asynchronous type means induction motors, which are most heavily used in industry and our everyday functioning. So we have to take care of selecting a proper starter. Friends, we start from types of AC motors. We'll learn about how many types of AC electrical motors are available. There are two main types of AC motors, synchronous and induction. Induction motors are the most common type of AC motor and can be found in anything from lifting equipment to household appliances. They are also known as asynchronous motor because they use electromagnetic induction from the magnetic field in the stator winding. This produces a current in the rotor. In a synchronous AC motor, the rotation of electrical rotor matches the frequency of the supply current. Therefore, the speed remains constant no matter the load, whatever may be the load. This makes it ideal for high precision positioning devices such as robotic solutions. Except for a small motor up to 0.3 HP, which are usually single phase, or large motors are manufactured to for three-phase operation. The principal type of three-phase motors are induction motor up to 1000 HP and synchronous motor up to 5000 HP. Let us know what is the principle of operation of induction motor. According to Faraday's law of magnetic induction and motion, it is obligatory to have three basic quantities if motion is to be created. First, a conductor forming closed circuit. Second, changing of the revolving magnetic flux or field. And third, passing of current in the conductor. In the three-phase induction motor, the three-phase AC supply to the stator winding sets up a revolving magnetic field which rotates at a speed of 120 multiplied by frequency divided by poles, where F is the frequency of the supply, and P is the number of poles on the magnetic winding. It is known as the synchronous speed of the motor. Friends, the revolving magnetic field interlinks with the rotor winding and induces an EMF, that is electromotive force, in it by induction. Since the rotor winding has a closed circuit, induced EMF in it causes current to flow in the winding. The rotor current interacts with the revolving magnetic field and thereby tend to turn the rotor in the same direction. We'll see this through a diagram in the next lesson. Friends, we are learning about a slip ring induction motor. It has got two basic parts. Known First one is stator and second is rotor. Stator stator is shown here, and inside it there is a rotor, and this diagram shows the bars of the rotor. Now stator, it consists of an outer cast iron body which carries slotted stamping on the inside of the house of the winding. The end covers which support the bearing for the rotor are also mounted on the stator. The winding is similar to that of an alternator. The speed of motor is determined by number of poles of the winding and is shown in the following table. You can see uh, the rotor is having a number of conductors enclosed, forming a ring type of system. The rotor has got slip rings. These slip rings from where the from through which electric current is given to induction motor. The induction motor has got a fan, a shaft, and end seal to cover it. Stator has got a number of the wound stator, and this induction motor has got a lifting hook through which the entire motor can be taken out. Friends, this particular slide shows the various diagram related with squirrel cage motor. The first diagram shows the stator and its winding. The winding may be contained in these slots here. The third diagram at the bottom shows squirrel cage of induction motor. A squirrel cage rotor consists of a laminated cylindrical core. The circular slots at the outer periphery are semi-closed. Each slot contains an uninsulated bar conductor of aluminum or copper. At the end of the rotor, the conductors are short-circuited by heavy ring of copper or aluminum. The diagram of the cage rotor is shown sidewise. Here in this slide, friends, we have shown two types of induction motor. One is slip ring type, in which this at the end slip rings are provided on the rotor, and these rotor from this slip ring the electrical conductor is conveyed to the motor. The next diagram at the bottom shows a wound rotor type of induction motor with slip rings, but this is a synchronous type of motor. Slip. The speed of rotor is always less than the synchronous speed. The difference between synchronous speed and the actual speed is known as slip and is expressed as a percentage of synchronous speed. So slip in percentage can be synchronous speed minus actual speed divided by synchronous speed. Slip of a normal induction motor varies with 1 to 2% at no load to about 4% at full load. When the induction motor is not having load, the slip is less and it goes on increasing according to load put up on the induction motor. Friends, the table here shows the synchronous speed of induction motor at two different frequencies. One 60 Hz and another is 50 Hz. In our country, we mostly use 50 Hz. So, if a number of poles are two, the synchronous speed at 360 Hz will be 3600, whereas at 50 Hz it is only 3000, and so on. It goes on vary according to the number of poles. The lowest speed is achieved by having 12 number of poles. Now, rotor is constructed of laminated steel sheets assembled around a shaft. The winding is placed in the slot near the periphery of the rotor. Ventilating ducts are provided for the circulation of cooling air. A fan is mounted at one end of the blow air. The rotor is supported on two bearings, usually a roller bearing at the driving end to take the end thrust and a ball bearing at the non-driving end. Friends, broadly there are two types of three-phase induction motors. First one is known as squirrel cage induction motor and second is known as bound rotor or slip ring induction motor. In the diagram in previous slide, I have shown slip ring type of induction motor. The squirrel cage induction motor is having either a single cage or double cage. First we'll discuss squirrel cage motor. The motor winding in case of squirrel cage motor consists of a set of copper and aluminum bars soldered or riveted to short-circuiting ring at two ends in a manner resembling a squirrel cage. In the case of induction motor with aluminum winding, the bars and rings and fans are all die cast in position without any soldering at the end. The aluminum conductor rotors are therefore more rugged. The slot in the rotor are sometimes skewed, that is, they are at an angle to the shaft to ensure quieter operation and better starting torque. In a small fractional HP motor, the rotor is sometimes made of solid steel without any winding. Such motors operate by virtue of the eddy currents set up in the rotor itself. Narrow longitudinal slots are out in the rotor surface to improve torque. Friends, we are discussing now high starting torque, normal starting current motor of double cage rotor type. The rotor of such a motor has two concentric cages as already shown in previous slides, one over the other. The upper winding has a relatively high resistance and low reactance and has lower winding, low resistance and high reactance because of its depth in iron. During the starting period, most of the current is in upper winding, and during operation, it is in this lower winding. The motor develops maximum torque at start, as shown in this side-by diagram. The torque developed by such a motor at any speed is sum of torque developed by the two windings and typical speed curve characteristic is shown as a curve V in this diagram. The other curve A shows single case torque characteristic. Friends, the upper diagram shows the cross section of a double case motor. There are two cages, one at the top, this one, and second is inner cage. So the first outer cage is in the outer periphery and inner cage is under the inner periphery, and the diagram here shows the uh, flux flow. Friends, now we are discussing wound rotor or slip ring motors. Unlike the scroll cage motor discussed in the previous slide, which has a winding fabricated out of bars, the rotor of slip ring motor is wired, wound, and in the winding terminal are brought out the three slip rings at one end of the shaft. The advantages of the slip ring motor are its susceptibility to speed control by regulating rotor resistance. Second, high starting torque of 200 to 250 of full load value. Low starting current of the order of 200 to 300% of the full load current. Hence, slip ring motors are used where one or more of the above requirements are to be met. The value of resistance for developing maximum torque at any speed is given by the equation R equal to S multiplied by X, where R is the resistance of rotor and S is the slip of motor and X is the reactance of the rotor. For a motor to develop maximum torque at the start, that is when S is equal to I, the resistance should be equal to reactance, which is constant for a particular rotor. It would therefore be seen that motor will develop maximum starting torque for one value of resistance only. For any other value of resistance, torque will be less than the maximum. It may be noted that the addition of resistance in the rotor circuit merely affects the speed at which the maximum torque is delivered and not the magnitude of the torque itself. Friends, now we are discussing how the induction motors can be started. For motors up to 3 to 5 HP, 3 in Mumbai and 5 in Delhi, dual starting can be resorted to, but the motor above 3 and 5 HP and up to 40 HP star delta starter should be selected. For motors 40 HP and above, auto transformer type starters are used. Induction motor above 50 cycles, uh, above 50 HP should preferably by slip ring type, but above 250 must be on slip ring type, which can be up to 1000 to 2000 HP. Above 2000 to 5000 HP, synchronous motors or synchronous induction motors, and above 5000 only synchronous motors are used. Starters are manufactured in two designs. One oil limos type and air brake type. Air brake type starters are preferred to oil brake starter on account of following disadvantage of the latter. First, high maintenance cost on account of carbonizing and sludging of oil brought about by repeated switching and load currents. Second, oil immersed starter are bulkier, heavier. Third, presence of the oil has danger of fire hazard. Fourth, oil brake starter cannot be assembled in multi-tier formation and therefore not amenable to group motor control center. Friends, the schematic diagram below in this slide shows the working of direct online starting. In this method of starting, motor is directly connected to supply in one step and no provision is there for reducing the inrush starting current. The schematic diagram of dual starter implying electromagnetic contactor is shown in figure below. Now these are the line current and this is the motor which by simply push, pushing up a switch comes on contact with the line and delivers the output. Friends, uh, the diagram below in this slide shows auto transformer type of starter. First, let us take how many different type of reduced voltage starters are suitable. They are mainly auto transformer starter as shown here in the diagram. Then second maybe short delta type. Third resistor in series type. Fourth reactor in series type. But only the first two methods are very popular. Friends, in case of auto transformer, there is a changeover switch and no volt and overload protections. Auto transformer is provided with tappings at 40%, 60% and 80%. The tapping selected for starting the motor depends upon magnitude of the maximum starting current allowed and minimum starting torque which is to be developed. Motor is started at reduced voltage, and when its speed reaches 80% of full load speed, supply is changed to full line voltage by means of changeover switch. For 40% tapping, the motor takes 16% line current and develops 16% starting torque as compared to corresponding value in dual starter. Auto transformer starter are costly and heavy as compared to dual or star delta starter and also have less wastage of power during starting. It is used for motors up to 25 HP where reduction of starting current is a prime amp and where reduction of starting torque developed is not harmful. With this type of starter, motor can have stator winding connected in star or delta in run position, unlike the star delta starter where starter winding of the motor has to be in delta in run position. Friends, in this slide, the schematic diagram of star delta starter is shown. In this starter, the six terminals of the motor winding are connected first in star, and when the motor has picked up speed, the connections are changed over to delta. The starting voltage of is root 3 times the normal voltage. The starting torque and the line current are reduced to one third of the full voltage value. The changeover from star to delta can be manual or automatic with the help of contactors and a time delay relay. Friends, let us revise the induction motor. Electrical induction motor starters are essential devices used to control start and stop electrical motors safely. There are several key functions. It control motor startup. They ensure that motor starts safely to reduce mechanical stress and prevent damage. The features are one protection. Motor starter protect against low voltages and overcurrent, safeguarding the motor from potential damage. Second, the type of starters. Common type include direct online, DOL, second star delta, uh, auto transformer type, and soft starter is suited for different application and motor size applications. They are, they are widely used in industrial setting to manage motor operation efficiently and safely. Friends, now we'll discuss the characteristic feature of three-phase AC induction motors. Three-phase AC induction motor is the most commonly used motor of industrial applications due to its following characteristic. 1. Simple and compact design and rugged construction. Second, low initial cost. Third, easy and reliable operation and simple maintenance. Fourth, simple control gear for starting and speed control. Fifth characteristic, easy availability of motor in various type of cooling and enclosing methods. The last and foremost that it has high efficiency. The main disadvantage of induction motor is that it is not easily susceptible to speed control. Friends, now we will minutely learn about different type of starter. First one, the manual starter, used for small motors where remote operation is not required. In this category, manual direct line dual starter. It can be hand operated, switch with overload protection. It's used for small motors up to 1 horsepower. These are low cost simple design. Second, magnetic electromagnetic starters operate using contactors and control circuits. In, they are direct on line starter, full voltage applied at the start, high inrush starting current, used for motor up to 5 to 75 HP. Next category is star delta starter. Motor starts in star, runs in delta, reduces starting current to about one third. Used to motors above 5 HP. They can be manual star delta or automatic star delta based on time. Third category, auto transformer starter. They are uses reduced voltage during starting. Starting current reduced to 50 to 80%. Used for large motors above 15 HP. Next category is rotor resistance starter, that is slip ring motor. External resistances added to the rotor, high starting torque with low current, used only for slip ring induction motor. Friends, the next category is solid state electronic starters, known as soft starters, gradually increases voltage, smooth acceleration, and deceleration, reduce mechanical and electrical stresses, used in pump, compressor, conveyors. Next category is variable frequency drive, VFD. Variable speed drive contacts both voltages and frequency, allows the speed control. Soft start, highest energy efficiency, used in HVAC, lift, escalators, process plants. Fourth, special motor starters. Friends, this shows the physical diagram of direct online starter, DOL starter. Friends, this diagram shows isometric view of a soft starter.